So to start you off on your weekend of work, we're going to work our way through the rest of this Unit 1.9 Acids, Bases and Salts topics. It's going to be mainly focusing on practicing writing equations of the reactions of acids. So let's start where we finished off yesterday, and that was looking at the reaction of acids with metal oxides and metal hydroxides, and this is on page 10 of your notes. What we said was that when a metal oxide or hydroxide reacts with acid, we get a salt and water. Notice this equation. What we're producing here is salt and water only, and so this is a type of neutralization reaction. By definition, neutralization is when an acid reacts with a base or an alkali to form a salt and water only. So this is a type of neutralization reaction. So we had a look at the reaction between copper oxide and sulfuric acid. And what we saw in that is that the colourless solution of the acid changed to blue. And that is because we are forming copper sulfate. Copper ions, when they're in solution, are blue. And that's why we saw the blue colour change. If you can't remember that, if you look for one of the other videos on my channel from last year, and it goes through a couple of videos of these types of reaction. So we then wrote our equation for copper oxide and sulfuric acid. So let's flick over to the next page and see if we can have a bit more practice in writing these types of equations. So over on page 11 we can see a series of other reactions of these type, a metal oxide or hydroxide reacting with acid. And what you need to do with this is always keep in your head the general equation. So that is that when a metal oxide or hydroxide reacts with acid, we get a salt, which we have to name, and then water. It's always going to be plus water at the end. So the first step in this is to always write your word equation. Never try to just jump straight to the balance symbol equation. So with sodium hydroxide and sulfuric acid, first of all, we can write the left-hand side of our word equation very easily. I'm going to write it underneath this just so I have room. Sodium hydroxide plus sulfuric acid reacts to give me my salt, which we'll name in a second, plus water. Okay, naming salts is very similar than with metals and acid. For the first part of the name, we look to the metal. Okay, and in this case, my metal is sodium. Yes, I have hydroxide after it, but I just ignore that part of the name. So the first part of the name of the salt is sodium. And then for the second part of the salt name, we need to look to the acid. And this time it is sulfuric acid. And so the second part of my name is going to be sulfate. Remember that sulfuric acid changes its ending to sulfate. So you can see we can have a very similar salt name as we would have met previously with the reactions of metals and acid. Okay, so it's now time to form our balance symbol equation. And for quite a few of these, we're going to have to do our swap and drop. So sodium hydroxide, first of all, we need to do our swap and drop for that. So what we've got there is we've got sodium, and then we've got hydroxide. Hydroxide is one of our molecular ions, and you'll need to look to the back of the periodic table for that. You'll see that it appears as OH minus. So the first thing I do is write everything down bar the charge. In this case, that is OH. Okay, I then look to the charge for my valency. It's just 1 minus, so my valency is 1. Sodium, then, I just look to the periodic table for its valency. Find which group it's in, and you'll see it's in group 1. And so it has a valency of 1. So when you swap and drop those, you get that the formula of sodium hydroxide is NaOH. Sulfuric acid is one you should just know, which is H2SO4. Okay, that's reacting to give us sodium sulfate. Again, I'm going to need to do my swap and drop for this. So I've got sodium, and then I've got sulfate, which is one of my molecular ions. Sulfate is SO4 2-. Again, first thing I do is write down everything bar the charge. So I write down SO4. And then I look to my valency, or look to my charge for my valency. And I can see that my charge is 2-, and so my valency is going to be 2. Sodium, again, was group 1, so its valency is 1. So we can see when I swap and drop that, the 1 swaps to the sulfate, so I don't need any brackets because there's just going to be a 1 outside it. But you can see that the 2 from my sulfate is swapping to my sodium. So I'm going to end up with a formula of Na2SO4. Okay, after that I've got water, which is simply H2O. Okay, we can see from this that it's not balanced, and so we're going to need to balance it. Alright, so the first step is that we make a list of the elements that we have. So we have sodium, oxygen, hydrogen and sulfur, and then make that list on the right hand side. Okay, how many sodiums do we have on the left? We can see we have just 1. How many oxygens? Be careful with this. You've got 1 here and 4 here, so that's a total of 5. Hydrogens, again, need to be careful. I've got 1 with my hydroxide and 2 with my sulfuric acid, so that's a total of 3. And sulfurs, I just have 1. On the right hand side then, you can see that I have 2 sodiums. I have 4 oxygens here, but 1 with my water, so that's 5. I have 2 hydrogens, and I have just 1 sulfur. Okay, so you can see that my equation is not balanced, and it's probably easiest to start with sodium, since we have 2 on the right and only 1 on the left. Remember, at this stage we can only put big numbers in front of the whole formula. And so what I'm going to do is put a big 2 in front of my sodium hydroxide. Then it's really important that at this stage you update your list as to how many of each atom you have. So I've affected my sodiums, and now I have 2 sodiums. I've also affected my oxygens. So it's 2 multiplied by 1, which is 2 oxygens, plus my 4 that are here, which is a total of 6 oxygens. Hydrogens now have been affected as well. I have 2 times my 1 hydrogen here, that's 2, plus the other 2 here, which is a total of 4. Okay, so you can see I've fixed my sodiums, but my oxygens and hydrogens are not balanced. If you look at hydrogens, I've got 4 here and 2 here. So I need twice as many on the right hand side. I fix that by putting a 2 in front of my water. I now have 2 multiplied my 2 hydrogens. And so I now have 4 hydrogens. And I now have 4 plus 2 times my 1 oxygen, which is 6 oxygens. So you can see my equation is now balanced, but we have to take that step by step. What I'd like you to do now is have a go at the rest of the equations on this page. So that's magnesium oxides and hydrochloric acid and calcium hydroxide and sulfuric acid. So pause the video for a second, give those a go, and then once you've tried them you can press play again and check through them. So the first example there is magnesium oxide and hydrochloric acid. We need to complete the rest of our word equation, and we do that by first naming our salt. Remember your general equation, we're forming a salt plus water. For our salt, we get the first part of the name from the metal, which is magnesium. And second part of the name from the acid. We've got hydrochloric acid here, and remember it changes its ending simply to chloride. Not hydrochloride, not anything else, just chloride. And we also then have water. Don't forget about your water at the end. So for my formula, I need to do a bit of swap and drop work. Magnesium oxide is simply using magnesium and oxygen. So don't overcomplicate this if it doesn't need to be. So you've got magnesium and then you've got oxygen. Magnesium is group 2, so it should have a valency of 2. Oxygen is group 2, so it should or group 6, so it should also have a valency of 2. We can see that that cancels down. Remember, we want our numbers in their simplest ratio. That cancels down to 1 to 1. Then when I swap and drop, I can see that those 1s will just cancel, and so I end up with MgO. Hydrochloric acid is simply HCl, and again that's something you should be familiar with. Magnesium chloride then. Again, this is just a very simple version of my swap and drop. I use magnesium, and for chloride I use chlorine. Again, don't overcomplicate that. Magnesium is group 2, so it has a valency of 2. Chlorine is group 7, so it has a valency of 1. When we swap and drop that, we end up with a formula of MgCl2. And then we have plus water, which is H2O. Okay, we can see my equation's not balanced, so let's take some time to balance it now. I have magnesium, oxygen, hydrogen and chlorine. And then I write that list on the right hand side. Okay, counting up how many I have on each side. How many magnesiums do I have on the left? I have 1. I have 1 oxygen, 1 hydrogen and 1 chlorine. On the right hand side I have 1 magnesium, 1 oxygen, 2 hydrogens and 2 chlorines. I can very simply fix this problem by putting a big 2 in front of my hydrochloric acid. That now gives me 2 hydrogens and 2 chlorines, and so my equation is balanced. The next example we have is calcium hydroxide reacting with sulfuric acid. First thing we need to do to complete our word equation is name our salt. First part of the name comes from the metal, which is calcium. Second part of the name comes from the acid, which is sulfuric acid. Sulfuric acid changes its ending to sulfate, and so the name of my salt is calcium sulfate. And then, as always, we have plus water at the end. Okay, so we need to write our balance symbol equation for this. And we need to do our swap and drop for calcium hydroxide. So first thing is that we've got calcium. Second thing, we've got hydroxide. Remember, hydroxide is on the back of your periodic table. It's OH minus. First thing I do is write down everything bar the charge, and that's OH. And then I look to my charge for my valency, which I can see is going to be 1. Calcium is group 2, so it's a valency of 2. When I swap and drop that, you need to be really careful with this. Because the 2 is swapping over from the calcium, it's applying to the whole hydroxide. That means it needs to apply to the oxygen and the hydrogen. So to show that, we put the hydroxide in brackets. It's really important that you remember those brackets. You won't be able to balance your equation properly if you don't do that. Then we're using sulfuric acid, which is H2SO4. Calcium sulfates, I need to do my swap and drop again. I've got calcium, and then sulfate is SO4, 2 minus. So first thing, write down everything bar the charge, including that little number 4 at the end. So it's SO4. And then I look to my charge for my valency. My charge is 2 minus, so the valency is 2. Calcium is group 2, so it also has a valency of 2. Those number 2s are going to cancel down to 1 to 1. Then when I swap and drop, I will get CaSO4. There's no number outside the brackets, so I don't need to include them. It's just CaSO4 plus water on the other side. Okay, my equation is not balanced, so I need to make my list. I've got calcium, oxygen, hydrogen and sulfur. Calcium, oxygen, hydrogen and sulfur. Let's count up, and we'll need to be a wee bit careful with this. Calciums, I've got 1. Oxygens, this 2 multiplies everything inside the brackets by 2. So I've got 2 times by my 1 oxygen, which is 2, but then I've got another 4 here, so that is 6. Hydrogens, again be careful with this. You have 2 times your 1 hydrogen here, which is 2, but I've got another 2 here, and that is 4. Sulfurs, I just have 1. On the other side then, a little bit simpler. Calcium, I've got 1. Oxygen, I have 4, plus my 1 here, which is 5. Hydrogens, I simply have 2. And sulfurs, I have just 1. Okay, so we can see that we need more oxygen and hydrogen on the right hand side. The only way I can fix that is by putting a 2 in front of my water. Now I need to update my list. I can see that I have twice as many hydrogens, so I've got 2 times by my 2 hydrogens, and that is 4. And then for my oxygens, I have 4 oxygens here, and then 2 times by my 1 oxygen here, which is 2. That's a total of 6, and we can see that my equation is now balanced. So for these types, it's really important ultimately that you remember this general equation. Metal oxide or hydroxide plus your acid gives you a salt plus water. So the last type of reactions of acids is acids with metal carbonates this time. And we'll have a look to see how our equation is a little bit different. And it's these general equations that are the most important things here. What we find when a metal carbonate reacts with acid is that again it produces a salt, but my side products are now water and carbon dioxide. Water and carbon dioxide. The easiest way to remember that is that your metal compound is called a carbonate. So I'm producing carbon dioxide. Okay, the main thing we'll do here is have a look at our equations, and then we'll come back to this in class next week. So you can see again we name our salt in exactly the same way as with the metal oxides and hydroxides. So the first part of the name comes from the metal, and so we looked in this case to see that it's copper, and so I write down copper and I just ignore the fact that it is carbonate. Then when I'm naming the second part of my salt, I'm looking at my acid, sulfuric acid, and so I change my ending to sulfate. So my salt in this case is copper sulfate. Let's have a look at some examples, and I will show you the reaction of these in school next week. First one we have is copper carbonate plus sulfuric acid. And just to let you know, copper carbonate is a green powder. It's a sort of turquoisey green, but it's just called green. And copper carbonate is green, and we'll see that next week. What we see with this reaction, and again you have to think of your general equation. So we can see from our general equation that we're going to produce a salt, water and carbon dioxide. And it's this carbon dioxide that I want to think of. What is carbon dioxide? Well, it's a gas. Anytime we are producing a gas, we're going to see bubbling. So even if you can't remember these observations in the exam, think what you're producing, and that should help you. So the first thing that we're going to have is bubbles of gas produced. Or fizzing is fine. Second thing is common with our metal plus acid reaction, and that's the fact that heat is released. Similarly, where the metal disappears with the reaction of metals and acids, the solid disappears in this case, and the solid is copper carbonate, so the copper carbonate will disappear. And then finally, just as with the previous type, with copper oxide and sulfuric acid, we see a colour change here. So again, think about what you're going from and going to. So we start with sulfuric acid, and that's a colourless solution. We're then going to be going to a solution of copper carbonate, and perhaps at this stage it is we could put in our products. So let's have a think of the salt that we're going to produce. Again, first part of the name comes from the metal, and so that's copper. Second part of the name comes from the acid, which is sulfuric acid, so it's going to be copper sulfate. We're then also, as our equation tells us, we're going to produce water and carbon dioxide. Okay, so looking at our salts, we can see that we're forming copper sulfate. We know that when copper is in solution, it is blue. So the colourless solution is going to change to blue, just as we saw with copper oxide and sulfuric acid. So colourless solution changes to blue. So we're thinking about what our products are and what we might observe from that. Calcium carbonate and hydrochloric acid, it's very similar. Again, think of what you're going to produce first of all. The name of our salt is going to be calcium from the metal. And chloride from the hydrochloric acid. As per our general equation, we're going to form water and carbon dioxide. So again, thinking of our products, we can see we're forming carbon dioxide. That means that we're going to have bubbles of gas produced. Again, we're going to see heat released and the fact that the solid disappears. The solid in this case is calcium carbonate. Calcium carbonate is just a white, either a powder or granule type form. And what we find with this is that the solution remains colourless. Above, the solution changed to blue because we had copper, but here we just have calcium as our metal, which forms colourless solutions. So the next thing we need to do is write our equations for these reactions. And again, always keep in mind your general equation when you're writing these equations, and I've written that at the top. So the first thing we need to do is name our salt. We can see the salt is the first product. So for the name of the salt, I get the first part of the name from the metal, which is copper, and just write that straight down. Second part of the name comes from the acid. Here I've got sulfuric acid, so the second name is going to be copper sulfate. Then I look to my general equation for the other products. I can see that I'm forming water and carbon dioxide, so I just simply write those in. Okay, now for my balance symbol equation. Again, we have to do a little bit of work with our swap and drop here. So for copper carbonate firstly. So copper is Cu, and carbonate appears in the back of your periodic table as CO3 2-. First thing with it is that I write down everything bar the charge, which is CO3. I then look to my charge for my valency. My charge is 2-, and so my valency is 2. With copper, it's in the transition metal block, so it doesn't have a group number. What you can do is look at the back of your periodic table and see that it's 2+. But also in this example, we're given the number in brackets. That represents the valency, which is 2. So finding your valency is the next step. We can see that our ratio here is 2 to 2, which we can cancel down to 1 to 1. When we swap and drop that, we can see the ones are just going to cancel, and so copper carbonate is just CuCO3. Sulfuric acid, you should know by now, is H2SO4. And copper sulfate we need to do our swap and drop for. So copper again is Cu, sulfate is SO4, as we've seen with previous reactions. So it's SO4 2-. First thing I do is write down everything bar the charge. So that's SO and including the 4 at the end. I then get my valency from the charge, which is 2 minus, so my valency is 2. Again, my valency of copper hasn't changed, so it is 2 also. Again, that cancels down to 1 to 1. And when I swap and drop, I'm just going to end up with Cu SO4. I also have water, and I have carbon dioxide. Carbon dioxide is CO2. We know that because it's carbon, which is C, and then di means 2, and oxide means oxygen. So 1 carbon and 2 oxygens. So let's make a list to see if this is balanced. So I've got copper, I've got carbon, I've got oxygen, I've got hydrogen, and I've got sulfur. I write that list then on the right hand side as well. Copper, carbon, oxygen, hydrogen, and sulfur. On the left we can see that I've got 1 copper, I've got 1 carbon. I need to be careful with my oxygens. I've got 3 here and then 4 here, which is 7. Hydrogens, I've got 2 here, and sulfurs, I've got 1. On the right hand side then we can see that again I've got 1 copper, just 1 carbon. Oxygens, I need to be careful. I've got 4 here, plus 1 here, plus 2 here, which is 7. Hydrogens, I've got 2 here, and sulfurs, I've got 1. So we can see from this equation, this list, that our equation is already balanced, and so we don't need to do anything more with it. So just be really careful, particularly with your carbonate ion. And we'll have a look at that in our next example. Our next example is calcium carbonate and hydrochloric acid. What I want you to do is pause the video and give that a go, and then I will go over it. So with this example, again, I need to keep my general equation in mind. The first thing I produce is a salt, and I need to name that salt. First part of the name comes from the metal, which is calcium. Second part of the name comes from the acid. The acid is hydrochloric acid, so that changes its ending to chloride. I then look to my general equation and see that I also form water, and I also form carbon dioxide, just as the example above. Okay, the first stage in writing my balance symbol equation is doing my swap and drop to get my formula. So first of all, we have calcium carbonate. Calcium is simply just Ca. Carbonate, I need to think about a little bit. Carbonate is CO3, 2 minus, that appears in the back of your periodic table. First thing I need to do is write down everything, bar the charge, including that little 3 at the end. So it's really important that you remember that. So I write down CO3. I then look to my valency, or my charge for my valency. My charge is 2 minus, and so my valency is 2. Calcium is in group 2, so its valency is also 2. I can see that that ratio of 2 to 2 will cancel down to 1 to 1. And so I end up with my formula of calcium carbonate, after I do my swap and drop, is simply CaCO3, because those ones are just going to cancel out. CaCO3. Hydrochloric acid is simply HCl, you should know that by now. And then I form my salt, which is calcium chloride. Again, don't overcomplicate this, we simply use calcium and chlorine. Calcium is Ca, chlorine is Cl. My valency of calcium is 2 because it's in group 2, and my valency of chloride is 1 because it's in group 7. When I swap and drop those, you can see that the 2 swaps over to my chlorine and the 1 swaps over to my calcium, and so I end up with CaCl2. I then form water and carbon dioxide, which is CO2. You should know that by now, but we can also see it from the name. Carbon, 1 carbon, dioxide, which means 2 oxygens. I need to balance my equation now, and so to do that I make a list firstly of all the elements I have. So I have calcium, I have carbon, I have oxygen, I have hydrogen, and I have chlorine. And I write that list on the other side in exactly the same order. Now to count up how many of each I have. I have 1 calcium, 1 carbon, 3 oxygens, 1 hydrogen and 1 chlorine. On the right hand side I have 1 calcium, I have 1 carbon, I have 1 plus my 2 oxygens, which is 3, and I have 2 hydrogens, and I have 2 chlorines. So we can see that the only things that are unbalanced are hydrogen and chlorine, and I fix that very easily by just putting a 2 in front of my HCl, which means I now have 2 hydrogens and also 2 chlorines. Okay, so take that step by step, take your time with writing those equations, thinking about what you're forming, and then writing your symbol equation from that. The rest of this page simply talks about how we test for carbon dioxide. So remember when we had a metal reacting with an acid, we produced hydrogen as a gas. How did we test for hydrogen? Well, it is the squeaky pop test, and remember that we write down that you apply a lighted splint and a popping sound will result. Here we've got a different gas being produced with the metal carbonates and acid, and that's carbon dioxide. The test for carbon dioxide is not the squeaky pop test, but instead it's lime water solution. So you can see here I've got exactly what my second reaction was, calcium carbonate reacting with hydrochloric acid. And what happens is the calcium carbonate, it will start to fizz because it's producing carbon dioxide. That carbon dioxide will come up, it will pass through this delivery tube and into the solution of lime water. Lime water is colourless originally, but when carbon dioxide gas is bubbled through it, it turns milky or cloudy. And this is your main observation that you want to write if you were asked how to test for carbon dioxide. So the test for carbon dioxide is that you pass carbon dioxide through a solution of lime water, and that's here. And lime water turns from colourless to milky if the gas is carbon dioxide. If the gas was hydrogen, like we saw before, lime water would just remain colourless. But that's the main colour change you need to learn here. Lime water changes from colourless to milky in the presence of carbon dioxide. So that's a way of confirming that this compound was a metal carbonate, because we know that a metal carbonate and acid produces carbon dioxide. And so if my lime water changes from colourless to milky, I know that I've produced carbon dioxide and that must have come from a carbonate. The very last part of this topic requires you to know the colours of the salts, and the only thing that can come up on this question is literally you having to state or maybe fill in a table with the colour of these salts. So it might be a good idea to colour code your notes a little bit. The copper, we can see here that copper salts have a different colour depending on whether they're in solution or whether they are just a solid. So copper oxide is a solid, and it's the reaction I did in class just yesterday with the black copper oxide powder. So it's a solid and it is black. Copper carbonate, we'll see on Tuesday, is a nice green colour. Again, it is a solid, it's a powder. So these two solids of copper are different colours. What we see with hydrated copper sulfate, that is sort of nice crystals of copper sulfate, is that they are blue, and copper salts in solution are blue. So if we have any solution of copper, be that copper chloride, copper sulfate, copper nitrate, it is blue. So you need to just learn those colours. With the rest of the salts that you need to know of, it's very simply that they are all white. So if they're copper, it depends which copper they are, whether it's copper oxide, copper carbonate, or copper sulfate. But with group 1, group 2, and aluminium, which is in group 3, for salts of those, they are all white. So think of group 1 salts, for example, would be sodium chloride, which is NaCl. Sodium chloride is your table salt, and it's just white. What happens when you dissolve table salt in water? You get a colourless solution. So for those group 1, group 2 and aluminium salts, they all are white solids. They form colourless solutions. How a question like that would come up, they would give you a specific one. So say they might give you magnesium bromide. They might ask you what colour is magnesium bromide, and you'd think, I haven't a clue. But you need to think back, okay, well, magnesium is in group 2, and so it forms a white salt. If I then dissolved it in water, it would form a colourless solution. What about if it was aluminium oxide, Al2O3? You think, I don't know what colour aluminium oxide is. Well, what I do know is that aluminium salts are all white, and so aluminium oxide must be white. And when I dissolve it in water, it must form a colourless solution. So those are general rules that you're learning for group 1, group 2 and aluminium salts, but you need to be able to apply them to specific examples. So that's the end of this topic. The key thing that I want you to take away from here is your general equations. I'll write them here now, but you should, on a piece of paper, practice writing them and learn them off by heart. And when you get into an exam, I would really advise that you take a piece of paper and you write down your 3 general equations just before you start answering any questions. It means if this comes up, you can look to them. So firstly, you've got a metal on its own reacting with acid. What's your general products for that? Well, we always get a salt, but this time our side product is just hydrogen. Okay, the next one we saw was a metal oxide or hydroxide. Reacting with acid. This time we produce a salt, but then I need to think about my side products, which this time is water. Then the last one we saw was a metal carbonate plus acid. That reacts to give us again a salt plus, and then I need to think about my side products. This time it is water. And then because I've got a carbonate, I am producing carbon dioxide also. So you can see that in each general equation, I always form a salt, but then my side products are different. With a metal, I've got hydrogen. With a metal oxide or hydroxide, my side product is water. And then with a metal carbonate, it's water plus carbon dioxide. And you can kind of see how these build from hydrogen to water to then water plus carbon dioxide. So when you get into your exam, go straight in, write these 3 general equations down, and that will help you if you're asked to write an equation for a specific example. So you may be given, what's the equation for calcium oxide reacting with acid? You would go straight to the second general equation. You could say, okay, well, I know when calcium oxide reacts with an acid, it's going to produce a salt. Yes, I'll need to think about the name of that salt, but it will also produce water, and that will help you with your equations. Okay, so you're ready now to do the questions on the acids, bases and salts. What was a test that I gave you yesterday, but just do those as questions. It would be very helpful for you, particularly in preparation for your mock on Thursday, if you have a look over and try and revise and learn this topic and treat that as a test. It's not essential that it's done as a test, but that will be much more helpful to you. Remember that your mock is on Thursday, which you'll need to know everything for. So you should start to learn these topics, especially as we have a couple more still to do. So take some time, look over these notes, learn your reactions of acids, bases and salts, and then give the questions a go. And then the electrolysis video will be up later.